Welcome to the Smart Podcast. It is the last video of this sessions of particle sum optimizations using neural networks and the data sorting using particle sum optimization as well as in neural networks. I'm continuously uploading this video, trying to upload all the things in YouTube. The reason behind for that whatever the problem I faced, I don't want those of the students will coming in this sections or in this way. Please, I think they will not bear the same things. That's why I think I will upload all the videos, all the details regarding this here in here. So in this sections I will discuss the results about. Before that I will tell you about some of the things. It is the academic projects. It is you should have to give some flavors. Then obviously we'll get some good results. There is a statement actually it gives about that if you love water, water also will love you. I don't know before 1 or 2 years before about the subcomputing, artificial neural networks, and machine learning, other things also. But after giving the lever too much, now I am in this domain. I think I'm quite good. I love the domains actually because it's have the features and next generations also. So it is the particle sum optimizations algorithms. So in this particle sum optimization, I'm started after that time to improve the particle sum optimization. That how we will apply the particle sum optimizations methodology in neural networks to train the data. So actually we'll get the success at the last. So my suggestions to you, please follow all the videos in this series one by one. I think it will give you complete idea. Might be it will be boring because it's a long video, because you know what is the perfections it gives longs. But another things, maybe my voice problem is this, really pardon me for that. I'm not very frequent as a Bengali also. My English may not be suitable for you, I think, but I'm trying to speak all the things in English. So please bless me in the features that I can go ahead and I can rather than find a good job, I can establish myself with good and reputed positions. So, okay, now let's start with the particle sum optimizations with the PowerPoint presentations of the PPT, whatever will be presents. This is the outline of whatever I will discuss in the PowerPoint presentations. I will make the video only 5 to 6 minutes, very short, please. Basic concept of particle sum optimizations. Particle sum positions is Swan-based intelligence systems inspired by the Falcon robot and source of peace is introduced and developed by James Kennedy and Russell Everett in 1950. It is dependent upon the local based and global based of the swans. It is widely used in the discrete and continuous functions optimizations problem. It is the basic diagram of particle sum optimizations, how the particle sum optimization they're moving from one direction to another directions, and how they will change their positions and their strategy it describes here. And some of the feature of the particle sum optimizations, they should have to maintain each of the particle in the swarms, it is described here. And this is the particle velocity and updation change each of the paper. If you go through each and every paper like this, it is the equation is same as particle velocity and updation change, position updation change. From to where you should have to learn about these things. Sorry, inertia trans, cognitive component, and social component you should have to learn which are the things. The application of particle sum optimizations, these are the domains where you can apply the particle sum optimization, artificial neural network, image processing, image recognition, data mining, operational research, and data set classification, optimization of power distributions. Each of the lots of enormous application of particle sum optimizations have. Now I'm come to the neural networks. What is a neural networks? About the very basic descriptions. About the descriptions, I'm going to forward the basic building block of artificial neural networks, and you should have to describe here all the things very detailed, at least 4 to 5 minutes about the neural networks. It is the connections and architecture of neural networks, about depend upon the neural network connections, we are classifying the architecture in three categories: feed forward, recurrent, and feed forward back propagations neural network also, and there is a small descriptions about that. And learning rule of artificial neural networks, there is a three types of learning rules: supervised, unsupervised, and reinforcement. In the applicants, very shortly will describe in front of you your guide and in front of your externals. And activation functions of artificial neural networks, which application function you are using, what their functionalities, how they works. In the activation function you will describe to in front of the guide when we will give in the presentations just within 3 to 4 minutes. And it is the neural data training with neural networks. In the data training, I used here feed for a neural network. Using it, I used 5 training functions as well as learning function. I use gradient descent learning functions, and it is the short-term forms of the mathematical short-term form for machine understandings of the algorithms whatever I used here. And layer of a neural network and number of neural layers. I discussed already that I used 2 layers for each of the training functions, and for each of the layers I used 5 neurons. Why I choose 2 layers, why not 3, and why I choose 5 neuron in each of the layers? You should have to give descriptions and small reasons about that. You should have to give in front of your guide or external. What is the benchmark datasets? On where you get the benchmark datasets, and this is the small descriptions about all the datasets, and some experimental terminology. What is the experimental terminology? It is the best, and it is the pointed out experimental terminology. What is you get? It is the experimental terminology of regressions for class datasets. Let's see the class datasets and experimental terminology, another things about the validations data, and about the plot regressions data, and error histograms also. I mean, after that it is your experimental results, where you consider the which type of parameters, the value parameter of particle sum of information you should have to describe. After that, what's the average value. After that you will get 14 datasets, you should have to describe in very proper manner. And experimental results also in the neural network will work. So using the neural network, how you train the data sets, what is the constants you will consider here, you should have to tell, and is the results, and along with the left side my result. After that you will compare your result in plot regressions results, error results, to the plot regressions result of neural network, and you will describe here that your functions, your result is good rather than any of the others five, any of the others 3 gradient descent algorithms. And this is the continue, what is the, what you get, what is the continuations, and it is the feature works the small, and few references is there. And that's the thank you for, I think that this much of any of for you. Okay, so thank you from my side also. So I think hopefully you enjoy all the videos. Please subscribe channels, like my video, and bless me for future further progress. With love, Palash. And if possible, try to follow me in Twitters, but I'm using frequently LinkedIn. So if you have any problems, query, if you want this project as well as this is PPT, all the things, please put me a comment or in the comment box. I will communicate with you. If you are suitable on these domains, I will give you with some conditions. Thank you.